I guess today is day 3. Today, day 3. Last session, I will discuss about the what is ASA and how is configuration and how is when he segmented discuss about the ASA. Now today is discuss about the why in Cisco ASA. Cisco ASA is the adaptive security appliance security appliance. So, what is ASA? ASA is a firewall of Cisco adaptive security appliance. Is a firewall of Cisco hardware or software device or system. In this ASA firewall, in this ASA firewall is is a control by the access to the network. In this IPS and VPN are these are in control by the these are is controlled by the networking. So what is the full form of IPS? Interaction Prevention System. Yes, system or VPN. VPN is also virtual private network. These are controlled by the Cisco ASA firewall. In nowadays, we like for example, in your computer is by using control panel like this control panel. That's same virtual private network are also one of the control panel of Cisco ASA firewall. Now coming to this, today we discuss uh, about the ASA firewall. Always these are supports like software firewalls can also be part of Cisco security solution. These are typically developed or servers or clients developed by servers and clients. These both types work together to enhance network security. These both are to work together network security. by monitoring and controlling incoming and outgoing traffic. In this monitoring controlling incoming and outgoing traffic. Coming to this chart, in this there are three different um, TCP TCP handshake of this overview of this process. What is TCP? First of all, what is TCP? TCP means Transmission Control Protocol. Is a transmission control protocol. So in this there are three different types of handshake, yeah, handshake of TCP. So coming to what are they means? First one is SYN, SYN protocol, and second one is SYN to acknowledgement protocol, and third one is acknowledge. First of all, what is synthesize? Synthesize means these clients send the synthesized package to the server to initiate a connection. And SYN is what is SYN? SYN is the client send a packet to the server to initiate a connection. This process ensures that both the clients and services are ready to communicate. And second is SYN acknowledgement. SYN acknowledgement is the server responds with a SYN acknowledgement packet, acknowledging acknowledging the receipt of the SYN. And third one is the acknowledgement. Acknowledgement is the client send an acknowledge packets back to the server and completing the handshake and establishing the connection. I will show the diagram in this process. So, but I describe how you might illustrate the TCP SYN process. First one is draw the line, horizontal line. Draw a horizontal line representing the connection between client and the server. This is this is A. A is a client and B is a server. Is a label and arrow from client A to client B. So client A to client server B to since is sent to the packets, sending to the packets, and client B is a server and client A is a client, and receive the from server B back to client A. Draw another arrow label. This is called as SYN acknowledge. And third one is this is step one, this is step two, and this is step three. Step three is a finally this is client A. This is server B. Coming to this, finally we what I told means client A to server B is a label acknowledge. This is a acknowledge. Hence, you can these three are is represent each step with the simple label them as three clarity of three steps of clarity. Now visually this three-way handshake effectively you have some drawing tool is mine. I can help guide you on how to create it. In this in to these are in is called TCP. TCP process. Here more details in this coming to down the chart. Client A to client coming to this chart, coming to this diagram. Client A to server B is a SYN. You know that. And in this line from client A to server B, client A to server B, So it representing the request to start a connection. This request to start a connection or send request to start a connection. Request. Sorry. Okay. Request to start a connection and representing them request to start a connection. Coming to step two. Step two is a server B and client A. This is called synthesis acknowledgement and acknowledgement. This diagram dash line from server B back to client A. These are indicated the acknowledgement of the SYN request. Acknowledgement of is sent to the this is sender. This is request to the request. Sorry, this is start request. This is only request. So and this coming to the step three. This is a client A server. Client A to server B is a acknowledgement. In this line from client A to server B is to indicate a finally acknowledgement. This is a connection state. You should add notes next to each step to indicate the connection state, such as before step one, these are closed. This is send request. Step two is sorry. This is closed step send. And coming to step two, this is a received request received. And the third one is step three is established. In this indicator timing, you can include small clock icons or the messages are exchanged rapidly. Coming to this visually, this present will clear show the three-way handshake process of establishing a TCP connection, making it easier to understand how SYN packet to are used if you have specific requirements or tools you do like to use it for the this diagram. Let's shoot. I can shoot. Let's break down the TCP. Let's break down the TCP. In this TCP handshake process and roll of sense packet in establishing a TCP connection. First of all, what is TCP? TCP is a the transmission control protocol. Is a fundamental protocol. Is used in networking to ensure a reliable communication between devices over a network. In this, it establishes a connection oriented communication channels. In this, there are three way of process. First one first one is step one is a since in the initiate is the client. For example, the client. This is examples of for example a web browser. A browser wants to connect to the server. A web browser is a wants to connect to the server. Example of server example is a web server, web browser and web server. Then this example is this one, and this example is, sorry, this one. In the purpose, this package initiates the connection and indicates the client's sequence number of which is starting point for the data transmission. So coming to second point, acknowledgement, synchronize acknowledgement. Sorry, synchronize acknowledgement. SYN synchronize acknowledgement. By mistake, full form is synchronize acknowledgement. This the response is coming to the step two. Synchronous acknowledgement is a receiving the the SYN packet, and server is acknowledges sending the back a packet with both back a packet is clients. This is server is the acknowledgement is by sending the packet both SYN and acknowledgement. In this action, the server includes its own sequence number in this packet. So indicating readiness to receive data by the client. Coming to this process, this packet confirms to the client that the server received its SYN and it is ready to establish a connection. So coming to the acknowledgement is a receive the SYN acknowledgement of the client package from the server. This client packet from the server. So this finally we discuss about the, and in this action the client responsibility acknowledgement packet indicating it has issued the server synchronized acknowledgement received the server. So then coming to the final process purpose of this packet completes the handshake and the connection is now established. Connection is now established. So this connection status during the process, the connection is closed and closes in synchronized synchronizing and synchronized received and exhibition. First of all, closing. What is closing? Close is the initial state before any connection is established. Syn sent, second one is synchronized to sent. These are in after sending the synchronized packet, the client enters this state waiting for a response. This is sending to the this synchronized packet sending to the client A. This state response for the server B. Waiting for response for the server. Okay, coming to the SYN received. Third one is SYN received. SYN means synchronized received. This server enter this state after receiving the SYN. B is a server. You know that this entire this state after receiving the SYN, receiving the SYN, and a waiting for the final a waiting for the final uh, acknowledgement acknowledgement. So finally, a stabilizer is once the handshake is complete, both client and server enter the state, allowing the data transmit. So in this importance of SYN flag, this SYN flag is a critical for establishing the connection reliably in and ensuring both parties and ready for communication. In this help is synchronizing the sequence numbers. For sequence number is, for example, what is sequence number? In TCP, the sequence number is a critical component used to keep track of data packets sent over a connection. Here's detailed explained. In this, what is a sequence number? In is a the sequence number is a field in the TCP header. Is a se- what is sequence number? Sequence number is a TCP is a TCP header that indicates the order of bytes in a data stream. It helps ensure that the data is delivered in the correct sequence. Data to data is helped to deliver in the correct sequence number, and allows the receive device to reassembling the data correctly. These are in the sequence number. Coming back to the there are coming back to the chart. Third, these are known as ASA firewall of TCP. Now, next, coming to this, what is the ASA? What is in this coming to the chart? Who is introduced by ASA? Is a name of ASA is a introduced by in 2005. His name is Ned Nedjuk. His name is Nedjuk. Is an introduced in the in the month May 2005. Is a introduced is a Pix Pix is a private internet exchange. These are in pre-configured rules. First one is L3 or L4, layer 3 and layer 4. And what NAT routing, VPN, virtual private network, and last one AAA. These these are these are in pre-configured configured rules. Is a coming to this, Pix is a first stateful of introducing New York, stateful of first New York, and in the year of 2005. Coming to 2005, another one network also is introduced. That name is Palo Alto. Palo Alto is a shortcut of PAN, Palo Alto Network, and now latest network update in next generation firewall. This is introduced by Gartner in the year of 2007, and in this two terminal was running in UTM. These two run this Palo Alto and NG next generation firewall is next generation firewall NGFW is introduced by Gartner in the year of 2007. These two, these two, these two are these two terminal was running UTM as well as and IWC. What is UTM system? UTM is the Unified Threat Management. Coming to IWC is the Intrusion Web Control. The UTM is the in the year of 2004, and this one IWC also in the year of 2004. This two is a is a introduction. Introduction is the name of Gartner, and next generation firewall is introduced by Gartner, also Gartner. This in the year of 2007, then introduced by Gartner, Palo Alto and NGW. Coming to Palo Alto, this Palo Alto is a layer 7 layer 7. This inspection is also there in this inspection. We also there. So layer 3 and layer 7. These are in production. There are 7 types of layers. Layer 1, layer 2, layer 3, layer 4, and also layer 7. Layer 3 is a IP protection, and layer 4 is a transport layer. In this IPS is a one box all features, and is a, in this year of Gartner is in the year of coming to Gartner. is developed in the year 2011 to develop is a number one like leader of Palo Alto and introduced Palo Alto and NGW, NGFW, sorry. Coming to what the difference between router and firewall. Is a layer 3 firewall and the layer 3 router and is firewall also layer 3 router. What's the difference? Router is allowed everything. Default, sorry, is default is allowed everything. And layer 3 firewall is default is is a block everything. In this router is right ACL means access control list. ACL yes control list. In this layer 3 in this router ACL is in when topic is when topic is delay topic is delay the topic is firewall is permit the topic and coming to the next part. So we discuss about the layer 3 and layer 3 router and layer 3 firewall ASA. Coming to layer 3 router, in this layer 3, in this layer 3 is of the OSI model is networking, is a networking networking layer. And coming to this firewall is a is also same networking layer, network layer. These are in layer. There are different there are 7 types of layers. That is in OSI model. What's the different OSI models are 7 types. First one is application layer, presentation layer, and session layer, transport layer, and data layer, network layer, and last one is physical layer. This is first layer, the second layer, this is third layer, layer 3, this is fourth layer, fifth layer, sixth, and this is 7 layer. Physical layer, network layer, and data layer, and transport layer. Coming to these layers, in this router functionality operates a layer 3. Coming to router functionality operates in layer 3 of the OSM model. Layer 3 is the model is network is a network layer. Sorry, two, this is two, and this is three. In this router package between different network based on IP address. So this supports various routing protocols. For example, in this routing protocol example is OSPF and BGP. I will explain after what is OSPF and what is BGP. I explain next session. Now coming to this router protocols. What is router layer? In this capabilities and this packet forwarding and routing is routing decisions to provide basic filtering based on access control list. It's based on access control list. I explained already this one. And this capabilities can perform this NAT. I explain also this one. First of all, what's NAT? NAT is a network. This is very important. Very important this one. Network address translation. I explained clarity of this one. And in these cases, interconnecting different networks of subnets or subnets. This managing traffic between local and wide area network. These are managing local area network or wide area network to manage this traffic. In this functionality, ASF coming to ASF firewall. Sorry. Coming to ASF firewall, this functionality is to act as security device, but also includes routing capabilities. These are security device or security domain. Security device, but also include routing capabilities. In this operates at layer 3 and layer 4 transport. Layer 3 is a network layer and layer 4 is a transport layer. Inspects traffic and enforces security policies. These are in layer 3 or layer 4. Coming to this capabilities to provide advanced features like state like stateful stateful packet and VPN support and IPS interpretation support. Intrusion prevention support. Virtual private network VPN means These offers more robust access control compared to basic routers. These are in when compared to routers, these are in more robust access control or a robust access control. These are more robust control access to compare the routers. Can this perform NAT and firewall server is say simultaneously to these cases to protect the network parameters level by controlling inbound and outbound traffic. In this to to control and outbound inbound and outbound of the traffic. This enabling secure remote access through VPN systems. This enable is secure remote access through VPN systems as acting as a point for deep packet inspection of our security threats. Is an inspecting security threats. Coming to the routers, routers is primarily to manage traffic between networks and while ASF firewall focus on security and traffic inspection. In the security features, ASF firewalls have advanced security capabilities, including threat detection and prevention, and which standard routers do not typically possess. What is different between routing versus security? In this routing, both can route traffic only. The ASI is a specifically designed to enforce security policies. This ASI is a specially to design to enforce security policies, making it more suitable to parameters defense. These layer 3 routers are essentially These layer 3 routers are is essentially for directing traffic within and between networks. And ASI firewalls combine routing function with comprehensive security features, making them ideal for protecting network environments. So these are in today's session. I will discuss about tomorrow. What is OSPF and BGP and what is network address translation. These are the discussion tomorrow. Thank you for interesting